Okay, so I haven't filled it out yet, but hopefully you have. We're going to do our distance formula. So we're going to call this x2 and this x1, although you could switch it around, but I'm going to do x minus h squared plus, sorry, trying to get the glare off of it, y minus k squared. And I take the square root of it all, and that's the distance from here to here, which is the radius. How are we doing with that? Is that okay? Do you see where every piece came from? So the x is our x2, and the h is our x1, and we subtracted those and squared them. It's just the distance formula. Now, the standard form for the equation of a circle, instead of having the square root in there, because the square root can be a little bit cumbersome, that means difficult to deal with, they're going to square both sides to get rid of that square root on there. So the formula that we would have for a circle is the radius squared equals x minus h squared plus y minus k squared. So here's what this means. It means that as we are looking at an equation for a circle, when we see a number all by itself on the outside, that's the radius squared. So we can just take the square root of that number and find the radius. The center is going to be filled in with the numbers that are here and here. So h and k will have numbers. The x and the y will stay x and y because they represent every point on the circle. So you would leave them in that x and y form. Just like think about an equation of a line where we'd have like y equals 2x plus 3 or something like that. The x and the y stay x and y for that equation of the line so that you can plug in an x and figure out what the y is. Same thing with here. You could plug in an x and figure out what the y is. And that's the basic form. Let me show you what an example of it would look like and how you could identify pieces. So there's two ways the book is going to have you go. One is they'll give you the center and the radius and ask you to write the equation. The other is they'll give you the equation and ask you to identify those pieces. So it's just back and forth. Let's start off with looking at the equation and then identifying the pieces. So you could have, and sometimes they write it where the radius squared is on the end, like that. Okay. So this is what an equation for a circle would look like. It's similar to a quadratic. If you think about a quadratic, has an x squared. This one also has an x squared, but it has a y squared as well. So that means it's different. Anything that's like a closed loop, like an ellipse, which you won't see yet, but it's like a squished circle or a circle, they all have this x squared and this y squared in it with multiple components that help us identify parts of that circle or that ellipse or whatever shape. Okay, so in this one, the radius and the center are the two pieces you need to identify. So you're going to press pause. You're going to try to figure out what would be the radius, what would be the center. And then once you figured it out, you're going to press play and then check your answer, okay? So pause. Okay, are you ready for your answers? The radius is going to be 6 because I just take the square root of 36. Remember, the equation had r squared for this part, so we had to square root it to get what the radius was. The center is going to be at 2, -1, and there's a trick in there. Remember, the formula says x minus h and y minus k. So x and minus are part of the equation, and then that 2 all by itself is the h. Y, there isn't a minus, so you have to think of this as minus -1. And then that's where we get our -1 from. That's probably the trickiest part of the whole thing. Okay, let's go the other way. Oh gosh, I'm running out of time again. Okay, I'll give you the problem. So the center is at 4, -1, and it has a diameter of 8. Ooh, tricky. They're giving you the diameter instead of the radius. So I want you guys to try that one and then check the next video for your answer. Okay, so you're writing the equation this time. You're writing the whole equation now. Okay, see you in a bit.